Martin, as she said. I'm out of Portland, Oregon currently. And let me get this off the screen. Anyway, a little background on myself is I worked for the Forest Service for about 20 years, finished my career with them as a fuel specialist, and then the last 5 years as a hotshot superintendent out of Santa Fe, New Mexico. And then I worked for Department of Interior, BLM, for 10 years as a fire ecologist. Um, since then, I've worked for Landfire on the fuels team with Tobin and Jim Napoli. So it's been a very busy winter for us at Fuels and Landfire, and it's looking like it's going to continue to be in through the summer, quite busy. So uh, I want to reiterate what Megan was saying. The questions you people ask really do provide a lot of impetus for us to improve products and gives us a lot to think about. So keep them coming, and we've got several to deal with on topics that were suggested for today's discussion. So Tobin and I, we got together and we talked this over, and we want to keep this as informal as possible. So we didn't develop a whole lot of slides or anything to look at. We just want to have a discussion with you folks and make sure that if you have any questions, we try and get them answered. The main topic of today's talk is about MODFIS, which MODFIS stands for Modeling of Fuels, Modeling Dynamic Fuels with an Index System. In other words, we wanted to base what we were doing on a credible, acceptable index in order to provide some variation to fuels depending on what the fire environment was telling us with climate and all sorts of other issues. So we wanted to make sure that we maintained that it followed an index system to give us breakpoints on where the fuels might be adjusted. And the whole thing came from after action reviews that Landfire used to hold after the fire season. And the people that would work on fires would come to these after action reviews and planners and tell us what they found in the data. Chuck McHugh, who's on the call today, was instrumental in a lot of those meetings. But anyway, in about 2009, we had one of these meetings, and it was suggested that, you know, these static fuel layers really don't work for special instances that come about, like in the Southwest, where if we have good moisture over the winter and spring, we have a flush of herbaceous fuels and fine dead fuels later when they cure. So that's a special instance that isn't captured in a static fuel model layer that Landfire was producing at the time. Same thing with the Southeast. They, you know, in the droughty years is when they tend to have their large fire seasons, and a static fuels layer is just not going to cut the kind of fire behavior they see in the real dry years and still work for their normal fire season setting. So we took that to heart, and we came back to work at Landfire and started to develop a couple of prototypes. And the one that we're going to focus on today is in the Great Basin Southwest, and it has to do with an index system of NDVI, which is what we base our stuff on, the index that we base our data collection and our outputs on. In the development of this, we wanted to make sure that we stayed within the Landfire project data. So we use their inputs for life form to start with for cover, and then we developed the system from there. So, you know, there was questions that we're probably going to get into after this introduction that are directly related to the fact that, yeah, we wanted to stay within the Landfire data, so we are using their base data to vary fuels according to that index system. Anyway, so with that being said, you know, it's kind of a broad overview introduction, but I think we'll get more into the meat of things. In the desert, in the Southwest and Great Basin area, as I mentioned, we're mainly focused on the herbaceous layer and how it affects the coming fire season. So maximum green up is what we aim to zero in on. We calculate what the fuels are different from previous years, different from average years, or different from max years. And then we apply new fuel models with that information for the current year. And Tobin is going to run through a couple of slides, but that's probably about all that we're going to bash into you as far as this system goes. And I think you'll learn a lot more about it as we just discuss it throughout the course of the hour. So Tobin?
Sure. Let me share my screen, and while I'm doing that, I'll give you a little background on myself here. If I can find my screen I need to share. No. So we will minimize that. Window. This was working earlier, and now I seem to have trouble getting to that window.
Sometimes the windows hide behind other windows, so.
Oh, you can move them around?
Yeah, well, you could, you might change the view from full screen to mid.
Ah, there it goes. Good call, Megan. Okay, we'll share that.
Got it.
Okay, cool. I'll maximize that, and I'll have to bring it back down when I need to get back to the other piece. So I'm Tobin Smale. I work for the Landfire Fire and Fuels. I started in fire when I was 19 on the Helena Ranger District on the Helena National Forest. Then I went to the Logan Hot Shots, and then the Lolo National Forest on the Superior Ranger District, working in fields there. Then the supervisor's office on the Lolo National Forest, and then the regional office for the Forest Service Region 1, then Fish and Wildlife, and then I've been with contractor to the USGS at Eros from then until now. And the majority of time, I think it's been almost 12 years or 14 years or something like that in Landfire. So what we're showing here is just a quick slide to show what we've created or the products that we distribute for ModFIS. And you'll see underneath these kind of yellow, green, and red blocks, this is all the area underneath that we're producing ModFIS products, and you can get those on the Landfire data distribution site. Charlie, I think, mentioned briefly about the Southeast ModFIS, which is embedded in WFDS, but this Southwest ModFIS is not currently in WFDS, I believe, and there have been some talks about uploading it or yeah, pretty much uploading it to WFDS. I don't know when that'll occur. But as we look at this slide, the big thing to take away here is there's these three blocks, yellow, green, and red. The green block in the middle is the central area, and that gets, we model ModFIS for distribution in June and also in July. So this middle section, so it gets modeled twice throughout the fire season. The upper section in the north is only once in July, and then the southern section gets modeled 3 times, June, July, and October. And let me switch to the next slide here. And I believe there's 15 map zones, if you're familiar with map zones. This is just a little area called a Dune State Park, which is just kind of a cool little area, and it helps show a little bit about how ModFIS modulates the fuel there. What we're looking at is these gray areas. These are the dunes, the sand dunes. So obviously those aren't going to grow fuel. And if you look at the legend here, that's fuel model 99, which is barren or rock typically. And up top here, it's split into two scenes. On the left is the average condition modeled in ModFIS. And then on the right is the 10-year average modeled, 10-year max modeled in ModFIS. So one of the things to look at is the amount of gray on the left where it's the average season versus a max greenness season on the right. On the right, there's less of that barren. So what it's doing is taking those areas that are barren or sparse and looking for greenness, and then we model those with fuel if there's certain levels of greenness that we modeled into the herbaceous cover. So we can see it grades from a gray on the left to this kind of lighter yellow, which is a grass model 1. And then it goes to an orange, which is the, I think, hopefully that's not covered on yours, but it's covered on mine. It's a grass shrub 1. And then as you get a little further out, it becomes a GR2 or grass model 2. And then this yellower color is, end of the slide shows what that is. There we go. Now we're back. This yellowish color is a grass model 3. So on the left, you can see how that graded. But if you look over to the right, we're going to have more of a grass model 3 where we're under our max condition, which is going to burn hotter. And we have less of the grass model 2, which is right here. And then a little bit less of the grass model 1, or maybe actually a little more in some areas. And then up next to the barren, we have very little grass model 1 in there. And then we have a little bit less gray, so a little less barren. And so the idea is we're trying to capture those times when we get enough, pre-season moisture to grow fuels for the fire models to capture. Let's see. I think that makes pretty decent sense. I'll leave this up for a few seconds, but I think that basically captures ModFIS in general. We can start with questions if you want, Megan, or you can keep talking a little bit longer if you like.
Let's open it up right now and see if anybody has any questions specifically about these slides or maybe related to their project peripherally. I do have a couple questions queued up, but there's people here that I'm sure would love to speak to you guys directly.
Tobin, this is Jim. I have a question.
Yeah.
Why is it 10 years? What is the reason we have 10-year max and 10-year max?
Yeah, that's a good question. So what we did was we took the well data, the web-enabled Landsat data, and they have an NDVI product for many years, NDVI, Normalized Difference Vegetation Index. And we took that over a 10-year period just to get an idea of what the average amount of greenness would be over 10 years, and then what the maximum amount of greenness would be over 10 years to give us, kind of some bookends to look at. But when we actually produce ModFIS, it's for current year for those different months that I showed on the other slide. So it's going to be somewhere for every one of the pixels in CONUS, they can, well, not for every one of them within that extent that I showed earlier, they can modulate between below average and then all the way up to that maximum condition. So the reason for the 10-year was just to give us, some bookends to look at when we were developing ModFIS.
So,
right?
So the product that downloaded is current year. Is that what you were saying?
Yep, it's current year. So
okay.
Yeah, one is north is once a year, central's twice a year, and south is 3 times a year.
Okay, thanks. That makes sense.
Yeah, I wasn't very clear with that, but yeah. So if you look at every one of these pixels, it can modulate to below average all the way up to, the maximum condition. And the important thing to remember is that if something is barren in the product, or even in our Landfire product, it doesn't mean that it can't grow fuel. It just means that that particular snapshot, it was barren enough that it wouldn't produce, or it wouldn't allow fire to spread through it, or sparse where it's a reduced condition. But you could have situations where those do grow grass, and they will. So in modeling them in multiple times a year, you can capture those and make it beneficial for fire modeling. Here, I'll stop my screen here. And I think it'll go back.
Thanks, Tobin.
Yeah.
If you don't mind, I have a follow-up, Tobin.
Sure.
Okay. Which is, have you compared static results of fire behavior analyses against these modulated fuels to see if there's a difference and whether it's closer to actual fire perimeters?
Yeah. I wish I could show my other screen. Okay. Yeah. We've actually modeled some fires actually to take a look at these. And we have seen that in certain situations, the static product that we put out in Landfire was not able to model, or was not able to spread due to certain conditions where maybe in Landfire we had, a sparse area that didn't have enough fuel in it. So when you start your simulation at that point, it won't spread anywhere. Or you could have the opposite effect that we've seen, where maybe in our Landfire product, we've got a decent fuel model in there that would spread. But if it was a dry season, in the Southwest, there wouldn't be that much fuel to spread. And then it would skew your simulation. So the ModFIS actually helps with giving you more of that current year herbaceous fuel. I can't remember the fires offhand. The Farad fire, I think we did, and there was a couple of them we did this year to show that as well.
Yeah, we did quite a few actually when we first started putting the program together, and a lot of the fires that we modeled, we didn't have good information on where the origin of the fire was, and they were historic fires. So, but as we went through this process and developed the data so that the field models would be more correct to spread the fire, we could actually find where the origin of that fire was, pretty close anyway. And it's all based on the weather that was current at the time from the closest remote automated weather station and those kinds of things. So I did have a setup of the Farad fire. If we have time at some point, we can take a look at it, and I can show you exactly what happens with some of the modeling. I'm going to have to get onto my other machine though real quick. I'll be right back. Maybe.
Yeah, we could field some more questions if you want, Megan, or whatever, and Charlie can get queued up.
We got 40 minutes for questions, folks, so don't be shy. Feel free to unmute yourself and ask your question. I'll
lower my hand and then go. So Charlie and Tobin, you can maybe comment a little bit about this. Not really a question, but as you're pulling things together. So use case, so we've got these, we're looking at the seasonality, across time. And of course, it's really important to look at, comparing seasons to seasons relative to what kind of fire behavior we, have in a particular year. I know that there are some units, let's take, say, like a BLM district or field office, that they are taking these to help with severity plans, step-up plans relative to, again, the growth or how conditions are changing based on that seasonality. And And so I think, that's a really good example of how people, can take this product and apply it. But I guess I'd be curious, Charlie and Tobin, if you've got any other comments you want to, kind of add to that, particularly as Charlie's pulling this up, because I think what Charlie will demonstrate and show is exactly, based on how conditions change, how it can help, a manager think about what resources need to be, in play relative to the conditions on site.
Yeah, I mean, it makes a huge difference if you're able to capture the fuels that are actually in the current fire environment compared to what was suggested it can burn like on an average basis. If you can get a pretty good indication of what exactly is there at the current time, it makes a world of difference in your ability to project out and get close to where the fire might go with your modeling efforts. So that makes a huge difference. And I think there's, like you say, there's quite a few different variations on trying to get at real-time data for fire and fuel modeling. But this is just one example. And I think, from our point of view and some of the people in the Southwest that use these products on an annual basis, that they find that it benefits them tremendously. They use it for some of their severity forecasts in the BLM on the DOI side in Arizona. They use it for actual on the ground modeling of fire behavior as well. So I think it's been advantageous for some folks to know, that ahead of fire season and then during the fire season that, yeah, we're going to have a lot more fine fuels this year to carry the fire than we've had the last couple of years. So they can make sure that they're prepared for that.
Yeah, for extra examples, Charlie reminded me of this, but we also did another video presentation a while back, and I don't know if it was like 2012 or 13 or I can't remember. What was that video? Anyway, it's on the Landfire website. If you look up Modfist, there's a YouTube video on there as well that'll go more into depth as to more visuals and things like that we've been looking at. Did you want to show that fire, Charlie?
Yeah, let me see if I can figure out how to bring up the screen here. Are you seeing?
Yep.
Okay, so let me start with an overview here real quick. This is the perimeter of the Farad fire, and it's no great big fire or anything like that. But it's a simple one that kind of proves the point. This is Interstate 80. This is the Nevada, California state line. I'll just zoom out real quick so you can kind of see. This is where Megan lives, right over in here in Reno, and then Truckee right off to the west here, if you're familiar with that area. But anyway, so the idea was this was a one shift deal. If you zoom in down here, you can see there's a parking lot right off the interstate here. And so we assumed that the origin of the fire was close by there. Somebody started the fire probably. But anyway, with Landfire 14, which is what we were modeling with the static fuel model layer, you can see these little rock bluffs in here. But if you start the fire ignition right down here at the origin where we figured it was, you don't get any spread because it hits this area and this is all barren in the static fuels layer. We'll take a look at that real quick. So this in this is the landscape file for Landfire 14, and black indicates barren and sparse, so or non-burn fuels. So if you start the fire right down here, it doesn't grow very much past that in that full first day spread, mainly because it bumps up against that non-burn and it can't go anywhere. In the ModFist landscape file, you can see all that barren has grass in it now. For this particular year, this was 2017. For the summertime of 2017, ModFist is telling us that even those little rocky outcrops, you can see a couple of sparse pixels there where those rocky outcrops were, but there's grass growing all the way around them for this particular year, this particular fire season. So what happens in the actual modeling, what we ended up doing was moving where we thought the origin was so that we could get some fire spread out of the static field model layer. This was what we would end up with if we kept the origin right down here where we thought it would be. That's as much as the regular land fire would spread. Let me turn that one off. And then, so we moved the origin just to try and get some spread out of it to see what it would do compared to the ModFist layer. And this is what we ended up with. And as you can see, it does spread. Once you put the ignition source up here, it does spread fairly well. It gets to the northern rim up here, but fire never gets established along the bottom. So it never carries through come here. It never carries through to this side of the fire, mainly because it doesn't get a good foothold down here on the bottom to carry through that way. It's all running over the top of these little hogbacks and then over the top of the last one and to the perimeter. So it's not a bad run at all. It just leaves out quite a bit here. With the ModFist layer, and these are standard Farsight runs, so nothing special about them. They use this weather and the fuel moisture data from a ROS, which is right up on the way to Truckee, not very far from the fire at all. This is the ModFist run. First time, no problem. Let me get the hours off of there. And as you can see, not only does it make the perimeter of the fire all the way across, it also overestimates a little bit along this corner and on the northwest side of the fire, where there's some pretty good fuels, it looks like.
Charlie, but, I have a question. What's the difference between the red and the blue and the teal and the yellow?
Basically, the red is, these are hours, okay? So we ignite the fire at 1300 in the afternoon. We take another look at the perimeter at 1500, so that would be the yellow one. And then at 1700, 5 o'clock in the afternoon, it's spread out to here, the blue one. Then by 1900, it's out to the edge of the perimeter of the fire. So if you were to cut off your burn period right then, you would have, a really close run as far as simulating this fire's final edge. After 1900, the humidity starts to come up. The fire slows down, and we ran it all the way out till the end of the day to 2300. And that's where we get the little bit of slop over, is the 2300 hours. So 11 o'clock at night. At 9 o'clock, I don't even see that line popping up. But the actual the best perimeter in the modeling stage is probably at 1900. So, you know, that would teach you, you know, if you were actually modeling this fire of what, you know, at what time, what approximate time to run your burn period, if you really wanted to get close. But I like to overestimate a little bit, you know, just to give people some slack.
Thanks, Charlie. This is a really impressive demonstration of the ability to adjust the fuels. And it's remarkable how close to the actual perimeter you got there.
Yeah.
Did you have the same ignition point, or did you go back down?
Yeah, I went ahead and ran the same ignition point for both of them in this particular run, okay, just to see. I did run a simulation from our original ignition point, and it ended up being about the same. There wasn't very much difference at all.
That's really good work.
We had a question come up in the chat window. You can leave this up if you want, Charlie, and I'll read this question. This is Chuck. Is there a connection to FuelCast? Then is there a methods or process outlined on downloading and incorporating these FD/FM changes into an existing landscape?
Well, first of all, FuelCast, we've worked with Matt Reeves on several occasions, and we're planning to get back with him as soon as we complete the remap process here, which probably be somewhere in July. But we've taken his data down. The last point that we discussed it with him, we had taken his data down. There was some mistakes in the way they were doing their calculations. So we pointed that out to him, and we haven't really had a chance to get back and take a look at the site since it's been revised. But I have seen some articles on it that it seems like things are working fairly well for him over there in that system. And it would be real interesting to try and see what the benefits are of the two systems and how they might interrelate together. And we plan to do that, you know, as time allows. The one problem that we did have originally with getting together with him was he was using that 250 meter pixel size. And that's one reason Tobin mentioned the weld data, and that's one reason we use the weld data is because it's 30 meter pixel, the same as the product we're working with in Landfire. When you start to bump up to 250 meter pixels, you have a lot of these small little areas that come in with grass that you're going to miss. It's all going to be, it may well be stamped shrubs or some other life form because the pixel size is so large. And these little tiny areas of grass in terms of making the fire available to spread are really important after they're cured. So anyway, that's kind of where we're at with FuelCast. As far as taking the adjusted FBFM 40 and putting it into an existing landscape, Tobin, you want to address that one?
Yeah, I believe you can still do that through the Landfire data distribution site and just download a landscape file with that fuel model checked. I'd have to check on that, but I believe that's the case.
No, you can't get the whole landscape. What you'd have to do is download that fuels layer and insert it into the landscape file that you downloaded. Because the only option is to download landscape files with the 13 and the 40, I do believe. So
They
But,
wouldn't, it doesn't include I thought it did, but maybe you're right. Maybe you're right.
We should check that, but
Yeah.
maybe they
But
added it.
Yeah, maybe. But you can still download it as a standalone fuel model layer. It would be nice if they updated that to put it in as an option for the landscape files. But otherwise, you would have to, I guess the easiest way to do it would be to draw your rectangle in the data distribution site and download that as a separate fuel model in your other layers as well. So they're all the same square or extent, and then build your landscape file through the new FLAM map, which Chuck is very familiar with, I'm sure.
Tobin,
yeah.
Chuck had something to say.
Yeah.
Yeah, I don't believe you can download the pre-built landscapes yet with that in there. So I was just curious because you've adjusted the fire behavior fuel models, surface fuels, but do you guys go along and adjust? You're only adjusting surface fuel models, not any other characteristics that might exist with it, right?
Yes, and that's correct. So the canopy fuels will still work with it because we aren't changing the canopy fuels at all. The only models that are changing are some of the up to 25% of the shrub life form models will change, and the herbaceous models. So that are within herbaceous and shrub life form, landfire life form. So you should be able to use the canopy fuels just the same.
I want to make sure we have time to address a couple other questions that were sent to me ahead of time. So Charlie, feel free to leave this up or take it down. It doesn't matter to me, but I think it's kind of cool to look at. So we had a fire ecologist from California who's on the call ask this, and I'm just going to read it. And feel free to chime in if I don't convey the question exactly. But so I have wondered if the ModFIS products to detect annual grasses might be useful in detecting certain type of vegetation change in Southern California shrublands at a landscape scale. For example, type conversion from evergreen chaparral to mixed shrub non-native grassland to annual grassland dominated vegetation by seeing an increase in annual grasslands. The second question, could annual grasslands be distinguished from drought deciduous sage scrub vegetation? Again, with the purpose of detecting type conversion from shrubland dominated sage vegetation to non-native grassland. And then the third question, I'll just cut and paste these and put them in the chat so folks can read them. Under extended drought, we have observed closed canopy chaparral opening up due to leaf drop, stem and whole plant dieback, and an increase in understory herbaceous growth. Could the increase in understory herbaceous cover be detected under these circumstances?
You want me to start, Charlie, or do you want to
go for it?
Well, so type conversion is a difficult one, and really it can only be identified if we go through and remodel each year and get new imagery each year and remodel the life form, which is not really what we're doing currently. We do have a system in place for the next set of updates for Landfire that will apply some rule sets to change the life form, but it's not looking specifically at the imagery itself to determine if there's a type change happening, right? So that's kind of the difficulty part. So with ModFIS, it's not going to detect it either because it's using the current Landfire life form that's modeled, in which in this case it's Remap 16 and 2016. And so if Landfire says it's herbaceous, ModFIS says it's herbaceous. If Landfire says it's a shrub, we will look at up to 25% of that shrub as possibly modeling it as herbaceous, because that's what's going to carry the fire if there's enough herbaceous component in it. And then the trees are always trees until Landfire remodels that life form and changes that actual life form that's in there. So once we get to the point of remapping on a constant basis with imagery, we should be able to do something like you're seeing. Yeah. Anything to add to that, Charlie?
No, that's pretty much sums it up. And that is the plan, I believe, at Landfire, to eventually get to a point where we can do annual updates, and we do them with imagery, imagery-based annual products, which should capture some of that. Now, being able to see the annual grasses under deciduous shrubs is always going to be a problem. It's going to be difficult to do. It's like trying to see the depth of the surface fuel layer through the crowns of trees from the imagery. It's not an easy thing to do. So I don't know how to respond to that one necessarily, but you know, if we have information that what's going to provide the fire spread is going to be the annual grasses rather than the deciduous sage shrubs that are decadent or dying anyway, then, you know, we'll know to map it that way. But we'd have to have information from the field that tips us off to that.
We had another question. Well, let's just see if anybody chimes in, but I have a couple other questions here. All right.
Megan, we should probably go to Jeff's chat question.
Oh, I didn't see something. Thank you for helping me.
You bet.
Jeff, okay, maybe there could be some analysis report on the differences between ModFIS and FuelCast to help the user community understand the difference and how to best use them, perhaps in concert, or to pick one or the other based on their needs.
Yeah.
Thanks, Jeff.
Yeah, I'm trying to think how you would compare those. You know, just off the top of my head, in looking at both of them, in developing ModFIS, we developed it pretty much specifically for modeling fuel, herbaceous fuel and fine fuel. And it's not really taken into consideration for, I mean, it could be helpful, I guess, for wildlife or forage or something like that. But that wasn't something that we specifically looked at in fire or for this product. Now, whereas FuelCast, forage is an important part of FuelCast that, you know, that Reeves has been looking a lot at. So it gears itself a little bit towards that. I mean, he's looking at pounds per acre and so on and so forth, where we looked at a modeled cover from NDVI. They're kind of two different approaches at getting at something. But also FuelCast does have some fuel model capability as well, in which I believe the way they get at the fuel models is determining the increase in the pounds per acre and then adjusting the current Landfire fuel map based on that. Whereas in ModFIS, we remapped the herbaceous fuel models altogether. We aren't basing them on what was currently there. So there's two different approaches, and I'm really not sure which one works better. We haven't really done that kind of analysis.
Jeff, tell us a little bit about where you're from and what. I'd love to hear from you.
Yeah, sure. And it's good to see some colleagues from my previous life. I worked with Henry Basham most recently on a WIFLC NISC fire and invasive species initiative when I was with the National Invasive Species Council. I worked with Tim Smith when I was trying to do state and transition models for invasives back at USGS. I'm currently with the Rocky Mountain Research Station as a program director for the Human Dimensions program, where Matt Reeves sits, and just trying to re-engage with understanding with Landfire and seeing where the current state of the work is. Looking forward to Leonardo Frid and his series coming up. That's what sort of reintroduced me to Landfire and this webinar series, and kind of going to this bake-off idea. You know, prior to all that other stuff I mentioned, I was at NASA in a validation, kind of coordinating, validating the products coming from Modis, the higher order land products. So, you kind of think about when we did comparisons of fire algorithms or the leaf area index algorithms, and you sort of, I think the trick, based on Tobin's answer, is kind of like what would be a reference data set for such a comparison. But you could think about sort of, after the fact retrospective analysis of fires and what maybe Modfis said, what Land Fuel Cast said, and which ones turned into big fires and were caught by both, which ones were fires that didn't match to one or the other, maybe because of their size, maybe because of just the characteristics, and then kind of have this idea of a bit of a matrix of if this is your interest, this is the pluses and minuses. My experience with the and at NASA with the Modis team was that it usually wasn't pick one or the other. It was know the difference and use them how you want to, or how it makes most sense for you. So I don't think it's and sometimes there were sensitivities in that community of it felt like somebody was saying one's better than the other, and I think the better analysis and the better papers, better reports, most useful were here's how they differ. NDVI and EVI is a great example. Well, when do you use one or the other? Well, you use both is what you do, and sometimes the difference between the two of them offered had this spatial coherence and a good difference. So we might find such an analysis might find that the difference where you see a big difference between Modfis and FuelCast could be this interesting map. And that's the type of thing that might come out of it. So that's just a quick background with my question, and nice to be included in this. And I've kind of got on my calendar to stay up to date with what Landfire is doing.
Well, just a little bit more kind of down that angle between the two systems. The FuelCast system tends to be loading weighted. In other words, the pounds per acre of the herbaceous really drives what kind of fire behavior you're going to see in those pixels. Whereas the Modfis product, at least in the Southwest and Great Basin, is more geared toward arrangement. So we use the cover to tell us how things are going to burn or what kind of fire behavior they can sustain. So if the cover tells us we have a lot of grass and it's spread out across the pixel, then we know we're going to have an area that needs an increase in the fuel model in order to get close to the fire behavior. With a loading-based system, you can have a little riparian area running through the middle of that pixel that has a lot of grass in it, and everything else is dry or sparse on the shoulders. But because you've got a heavier loading, you may well overpredict the fire behavior that could occur on that particular pixel. But just something to keep in mind when you think about the two systems. But again, we need to get back with Matt, because I know he's been making some great strides, and make sure that we're still understanding his system the way he's putting it together. And we're looking forward to doing that probably late summer, early fall.
Yeah, one additional thing that became that's a very obvious difference is when I showed the extent of where we are modeling in the Southwest Modfis. Ours is a much smaller area than what's in FuelCast, so that would definitely be the first thing that drove which one you would use. Because I think FuelCast is I think it's a very large area, if not all the U.S., but it's at least all the West.
I think it's just west wide, but it is all the West.
Yeah, but a lot bigger area than what we have for Modfis.
We had a question. Is there anybody else that wants to add to that?
Jack still got his hands up. If maybe Jack needs to go next.
I don't have add on to that just a mea culpa and a correction in the data distribution site. It does show the mod, it doesn't say MODFIS in there, but it says US_SU for summer, US_SP for spring, FA for fall, but they're still from 2020. So you can download a landscape with
That's great.
those updated fuels. So just wanted to offer that as a correction, but it looks like 2021 spring hasn't come out yet.
Oh, we just got the data.
Yep, by June.
Thanks, Chuck. Hey, in the postcard, I said we were going to address these 3 questions, and I'm not sure we're going to be able to blast through them in the last couple of minutes, but I wanted to at least try. So we had a user from the Nature Conservancy ask, I could use some help with understanding the fuels modification process, especially the total fuel change tool. And Tobin, we talked about this earlier, and I'm just going to put the resource that you had suggested in the chat window. So if folks have questions about the total fuel change tool, that document should help clarify things. Did you have anything to add to that, Tobin? And I can put in the Landfire, the help desk number or the email if folks have other questions about that.
Yeah, not a lot to add, but I mean, that's a good starting point, you know, so that they can get going on working with the Landfire total fuel change tool. And it's used quite a bit for really getting the Landfire product altered for really fine scale stuff. There's a number of people that are using it now. You can adjust all the way down to a district or a fire on a district or a prescribed area, maybe a NEPA document if you need to make some adjustments. But it's been very helpful, and that's how we model fire for land, or model the fuel for Landfire.
Thanks.
Mm-hmm.
And then we had someone from the Mississippi National Forest ask, I'm interested in using Landfire products for fire modeling and calibrating field data. And we had discussed this earlier, Tobin. Can you elaborate for a second on that?
Yeah, sure.
Is that person on the call first? Because I'd love it if that person was on the call, but I'm thinking not. No, sorry, go ahead.
Okay, well, it really depends on what your field data is, right? If it's to adjust the vegetation first, or what have you collected, right? If you've collected vegetation data, if you've collected fuel data, if you've collected vegetation data, then you would probably want to adjust your vegetation, or at least compare it to the Landfire vegetation first, and make adjustments to that vegetation before modeling it again using Landfire total fuel change tool, for example. If your collection data is, and I guess that would work for, say, plot data as well, but say if your collection data is more fuel specific, then I would go straight to the total fuel change tool and make adjustments based on what you've collected that way.
Hi, my name is Ellie Polzer. I'm not sure if it's me or if it's another person that's on the call that hasn't spoken up yet. I actually don't work for the Forest Service in Mississippi. I work for the Fish and Wildlife Service, but I'm supporting some of their processes as much as possible. And one of them is some ecological condition maps. And I may have asked that question that you just posed, Megan. The data are stand level. Some of it's fire related, some of it's not. So there are some gaps in my knowledge in respect to what is available sort of locally, regionally, but I was trying to find what the applicability of the Landfire data could be to my analyses.
So Ellie, is the data stated in terms of vegetation or in terms of fuel models or what?
In vegetation data.
Okay, yeah. So what you would probably need to do, or I guess the way I'd approach it is I would compare what that stand data has in it compared to what Landfire vegetation says is there. And if the correction needs to be done in terms of vegetation, then you need to start with that. I mean, in land fire, we build the fuels off of the vegetation layer. So whatever they whatever we're given for vegetation on a particular site, that's what we use in order to develop the fuels models.
Okay. I may have some follow-up questions eventually, but thanks for that in a preliminary sense. Thanks.
Would it be best for her to email you directly, Charlie, or the help desk?
Either way.
Okay.
Yeah, I'm pretty easy that way.
Okay.
Yeah, and the other option too is if you do email the help desk, let them know that it is vegetation centric, right? And then they can also get you in line with all our vegetation mappers and things like that to help answer some of your questions as well.